Hi guys, so this is 1.4. We're looking at combinations of functions. Some of this will seem like review, but there are some parts in here that are brand new to some of you. So let's keep in mind that when we have something within the parentheses, we are substituting this in for every x. So the idea is that every x I see in f of x, I am going to replace it with 2x. So I have negative, and now remember, instead of x, I'm going to put this 2x in there, squared, plus 3. Now instead of x, I have the 2x plus 4. So that's with evaluation and stuff. Now, what this is having us do is simplify all the way, okay, guys? So 2x squared is 4x squared, but there's a negative out front, so negative 4x squared. And then 3 times 2x is 6x, and then plus 4, and we're done. Okay, so when it's on the inside, remember you're evaluating it. You're substituting each for these x's. As you can see here, the 2 is on the outside. So I am taking all of this f of x, which is negative x squared plus 3x plus 4, and I'm multiplying the whole thing by 2. So of course, when I simplify that, all I'm doing is distributing that out to get negative 2x squared plus 6x plus 8. All right. Again, this is on the inside, so I'm replacing all of my x's with x plus 2. So I start out with negative. Now instead of x, I'm going to put x plus 2, and that's squared, plus 3. Instead of x, I'm putting x plus 2 plus 4. Now, sorry, I should blow my nose. All right, now in this case, we have a couple more things to do to simplify. First thing you want to do is FOIL that out. Remember that x plus 2 squared is x plus 2 times x plus 2. Okay, you don't square just the x and the 2. And I'm going to leave that negative out front first. So when I FOIL that out, I get x squared plus 4x plus 4. I'm going to distribute that 3 out, so I get plus 3x plus 6 plus 4. Now, remember that this negative will be distributed to all of this in the parentheses. Because I'm running out of room, I'm going to do that and combine like terms all at the same time. So right away, I just have negative x squared. Remember, this is a negative 4x. So negative 4x and 3x is negative x. Then we have negative 4. Well, that cancels out that 4, leaving 6. This is great because it's on the outside. So all I have to do is take this negative x squared plus 3x plus 4 and add 2 to it, giving us negative x squared plus 3x plus 6. All right, so here we have an f of x. So I'm going to write just f of x out. Negative x squared plus 3x plus 4. And then we have f of 2. Remember that we are replacing the x's with 2. So plus negative 2 squared plus 3 times 2 plus 4. All right, and that gives us, let's look at this. So that gives us negative x squared plus 3x. Now, you know what? I'm going to evaluate this right on top so I can just combine all the like terms here. So this is negative 4, this is 6, and that's 4. So those two cancel, and then 6 plus 4 is 10. There we go. Okay, so here is a wrap up of everything because there's other forms. So you saw how above we had f of x plus f of 2. There's other ways that we can write what that means. So you want to get familiar with how this is interchangeable. Okay, so f plus g is the same as f of x plus g of x. F minus g is just f of x minus g of x. Same thing with multiplication and then division. But specifically with division, g of x cannot equal 0. Otherwise, we'd be dividing by 0, which we cannot do. Okay, so let's look at some of the things they give us. So what we're going to do is f of x minus 1. So there's a couple things we can do. We can either add the two together and then substitute in the negative 1, or we can actually rewrite this as f of negative 1 plus g of negative 1. Okay, so f of negative 1. That is 6 times negative 1 squared minus 2 times negative 1. And g of negative 1 is 3 minus 1 over negative 1. So what's going to happen, guys, is I'm going to evaluate these two out and then add them together. So this gives me 6 plus 2, which is 8. This gives me 3 plus 1, which is 4. And remember, it's asking us to add them to those two together. So we get 12. All right. F times g of 2. Okay, so again, I actually think it's faster if you do the two separately. So f of 2 times g of 2. So I'm going to write this all out again just so you can see it. So it's going to be 6 times 2 squared minus 2 times 2, because that's what we're substituting in is the 2. And then g of 2 is going to be 3 minus 1 over 2. So let's see what we have on this side. That's 4, 24. 24 minus 4 is 20. And then 3 minus 1/2 is 2.5. But I'm going to keep that in as a fraction improper. So that way it's easier to multiply straight across. This is 2/2. Okay. And then again, we're going back to our operation, which is multiplication. So our answer is 50. Okay. All right, example 3 here. As in example 2, let f of x and g of x be the same as before, and find and simplify g minus f of x. Determine the resulting function. With subtraction, no matter what, be careful of the order, because as you can see, this is different than the other two we did, because g comes first. So I have 3 minus 1 over x minus. Now here's the other thing with subtraction. Make sure that you have those parentheses in there, because we're going to have to distribute that negative out. If you forget those parentheses, you will get the answer wrong. All right, now what I can do is I want to simplify this so I can check out the domain. So I'm going to distribute that out and get 3 minus 1 over x minus 6x squared plus 2x. Now, as you guys can see, I can't combine like terms, but there's a problem here. We have a denominator of x, and the easiest way to figure out domain is to make sure that everything is under a common denominator. So I'm going to multiply everything by x over x. Okay, so now multiply everything by x over x. Except for this one, because we already have that common denominator, right? So x over x. Okay, when I simplify that out, that gives me 3x over x minus 1 over x minus 6x cubed over x plus 2x squared over x. Okay, what we're going to do now is bring it all together so it's over the same denominator there. And by the way, I'm going to order from largest exponent to smallest exponent in the numerator. Okay, so I would get negative 6x cubed plus 2x squared plus 3x minus 1 all over x. Now we can talk about domain. What is it that x cannot be? X cannot equal 0 because we can't divide by 0, remember? So if we were doing interval notation, it would be negative infinity to 0, 0 to infinity. Okay, very good. Example 4, we have division here. Okay, again, watch that order. So right now, if I just write this out, I get 3 minus 1 over x all over 6x squared minus 2x. Okay, we're going to have to do some algebra in here, so make sure you bear with me. The only way I can combine this up here is to have a common denominator. So I am going to have 3x over x. So I'm going to multiply it by x over x minus 1 over x all over 6x squared minus 2x. Now that I have a common denominator, I can put it together. So I have 3x minus 1 all over x all over 6x squared minus 2x. Okay. Remember, a fraction over a fraction, just like this. So if I go a over b divided by c over d is the same thing as a over b times d over c. Okay, so if you look here, I'm multiplying a and d together, a and d together. And don't forget, this would be over 1. So I'm multiplying a and d together and multiplying b and c together. So this gives me 3x minus 1 all over x times 6x squared minus 2x. All right, we have more simplifying to do, guys, because look, there's something in common here. So the numerator stays the same at 3x minus 1. And as you can see, I can take a 2x out, leaving a 2x squared. It's 2x squared because there was already 1 out there. Okay, so 2x times x is 2x squared, leaving 3x minus 1. What happens? These two cancel, which give us 1 over 2x squared. All right, couple things we need to talk about. Well, first of all, as you can obviously see from below, 2x squared cannot equal 0. So when I solve for that, I get x can't equal 0. But the other thing I must keep in mind are things that canceled out. Those are the wholes that we used to have in secondary 3 that we went over. So I still have to say that 3x minus 1 cannot equal 0. And when I solve for that, I get x can't equal 1/3. Now, if I write the domain, I go negative infinity to 0, 0 to 1/3, and 1/3 to infinity. Okay. All right, this one's gonna be a little bit different. Those of you who did calculus already, this will look familiar, but take it slow. Given a function f, the difference quotient of f is the expression. Okay, so again, if you took calculus already, this is clear. If not, it will become more clear in calculus. But in other words, we're substituting x plus h in for x. We have f of x and over h. All right, if I can turn the page, that would be great. All right, so what we're gonna do is use the difference quotient to solve for these things. Be careful of your algebra, okay? So let me put this on top. The difference quotient was f of x minus h minus f of x all over h. And of course, I wrote something down wrong, right? Because it's x plus h. All right, I am going to do this in colors so you can see, okay? So if I start with f of x plus h, what I'm doing is I'm substituting x plus h in for every x I see. So I would have x plus h squared minus x plus h minus 2. So that's just me substituting in the f of x plus h. Now I'm going to subtract the actual just f of x. So I'm going to minus, now I have to put parentheses down because I have more than one term and I have to distribute that negative out. So that's that second part. And then the third part is all over h. Now, to actually break this down, we're going to have to do some algebra. So we're going to have to multiply out here, do your FOIL, distribute, and then combine like terms. So let's FOIL first. Now, if you FOIL this x plus h, you get x squared plus 2hx plus h squared. Now I'm going to distribute the negative out, so you get negative x minus h minus 2. And of course, I'm running out of room, so be careful. I'm going to distribute this negative out, negative x squared plus x plus 2 all over our h. Okay, so I FOILed and distributed the negatives out there. Now, if you can see here, I have some combining that I can do because these x squareds cancel. Let's see what else cancels here. The 2's cancel, and these x's cancel. So let me write down what we have so far. We have 2hx plus h squared minus h all over h. there's something else we can do. What is common in all of these terms? All of the terms have an h. So I'm going to divide every term by h. 2hx divided by h is 2x. H squared divided by h is h. Negative h divided by h is negative 1. H divided by h is 1, so that's why it cancels. If you can see, guys, I can cancel 1 out from each of these. Just be careful that this is negative 1, okay? The other way you could have done this, and I'm going to show you on the side here, is instead you could have factored out an h and gotten 2x plus h minus 1 all over h. And then you could have canceled them and seen that a little bit better. Okay, B, this one's going to get a little bit more complicated, so watch your algebra. Okay, so I'm going to put the green because I'm replacing x with x plus h. So I get 3 all over 2 times x plus h plus 1. Okay, that's my x plus h minus 3 over 2x plus 1 all over h. Whew, getting a little complicated here. All right, so first thing I might want to do, and I'm going to save myself some room, is I'm going to distribute this out so I can look at this a little bit better. So 2x plus 2h plus 1. Okay, so that way I ignore that. The reason why I'm doing that is because it's going to be easier to multiply that after. Because again, how do you combine fractions? You have common denominators. So if you look, what's missing here is the 2x plus 2h plus 1. What's missing here is the 2x plus 1. Do you guys see now that these two, so this denominator and this denominator, are the same? And whatever I do to the bottom, I must do to the top. Whew, tons of algebra. All right, so I'm going to just write this out as I see it. So on top here, I get 3 times 2x plus 1. And I'm going to subtract 3 times 2x plus 2h plus 1. That will all be over that common denominator. So I'm just going to put that together. 2x plus 1 times 2x plus 2h plus 1 all over h. Now be careful. A lot of you might want to cross those out. You cannot cross anything out until your final step. The other thing you know this is because there's a subtraction there, so you cannot cross it out. But what I can do is do my denominator. Remember, you multiply by the reciprocal. We did that on the other side. So right now I have 3 times 2x plus 1 minus 3 times 2x plus 2h plus 1 all over h times 2x plus 1 times 2x plus 2h plus 1. Okay. Not done yet because we have to be careful of our distributing up here and combining like terms. So we get 6x plus 3 minus 6x minus 6h minus 3 all over that denominator still. Lot to write down, guys. Okay, now let's see what can cancel. So I can cancel the 6x's out, and I can cancel the 3's out. And look at what we can do. Since we only have this top term right here, that means we can cancel out this h. So our final answer is -6 all over 2x plus 1 times 2x plus 2h plus 1. Okay, function composition. If you took calculus, you know what this is. If you haven't taken calculus and you're coming out from secondary 3H, this is going to be something new. But if you know how to evaluate and substitute in, this just might be a little tricky at first, but it's the same thing, okay? All right. One of the things that you need to remember with composition is just like order of operations. You always do what's in the parentheses first, okay? So one of the things I want to show you is how it's written. If we have G of, I say G of X, okay? That's composition. What that means is that the f of X is in G, okay? Just like if we said f of G, what that would mean is we have f of G of X, okay? Now, how does that go with us? So I'm going to rewrite it. So we see in A here, we have G of f of X. I'm going to work inside out. So I'm going to replace f of X with the actual function. So I have G of, instead of f of X, I'm going to put this 2x plus 3. Now, just like we did on the first page, what that means is we're going to substitute in x, 2x plus 3 for every x we see in G. So I'm going to start writing G. So I have 1 divided by, now instead of x, I'm putting in that 2x plus 3 and continue minus 1. See how this looks like G of X? But instead of X, I put the 2X plus 3. And of course, I can combine that 3 and -1. I get 1 over 2X plus 2. Okay. All right, I need this on the side so I can see my function. So f of G of X. Substitute in that G of X, so f of 1 over X minus 1. For every X that I see in F, I'm going to plug this in. So F starts out by saying 2. Now, instead of X, I'm going to put that 1 over X minus 1 and then plus 3. So again, look, this looks like f of X, but instead of X, I put that X over X minus 1. And then we could simplify that to see if we have anything that we need to do. So this would be 2 over X minus 1 plus 3. I need a common denominator. So I go 2 over X minus 1 plus 3 times X minus 1 over X minus 1. And then I can combine that to 2 plus 3x minus 3, because I'm distributing that out, guys, all over that common denominator of x minus 1. And I can do the numerator there, right? So I get 3x minus 1 all over x minus 1. And there's nothing else we can do, so we are done. H of f of x. So replace that f of x in there. So it's 2x plus 3. Okay. I'm going to write the h of x, but instead of putting x, I'm putting this 2x plus 3. So if we look at h of x, it's the square root. Now instead of x, I'm putting 2x plus 3, and then this plus 4. So again, it looks like h of x, but instead of x, we have the f. Of course, we can simplify that a little bit more. We get 2x plus 7. Square root of that is. F of x. Inside, out. So f of, now replace that f of x with 2x plus 3. And then I'm going to replace the x with 2x plus 3. So we get 2. Instead of x, we're going to do 2x plus 3 plus 3. Again, f of x, but instead of x, I have an extra. Now I can simplify that more. I get 4x plus 6 plus 3, which gives me 4x plus 9. All right, I'm not going to do E. It's a lot of algebra in there, but I'm hoping we get the idea. What I really want to do is go to F, because what that is telling me is H of G of F of X. So I see the order, guys. I'm going to replace one at a time. So H of G of F. So that's 2x plus 3. Now, okay, now what I want to show you here is that we already did this, didn't we? We did it on A. So luckily for us, we already got it that it was 1 over 2x plus 2. So I'm going to replace that. So it's h of 1 over 2x plus 2. So I'm going to start writing h, which is the square root. Now, usually you would have x right there, but we're replacing it with this 1 over 2x plus 2 plus 4. We want to simplify that more. Okay, so common denominator. So I get the square root of 1 over 2x plus 2 plus 4 times 2x plus 2 all over 2x plus 2. If you guys don't mind, I'm going to distribute that and combine like terms. So here we have 8x. That's 8, and plus 1 is 9. And remember, on the bottom right common denominator, you only need one of them. And since this was h of x, there's a square root there, and we're done. All right, Now that we know how to do composites, let's look at how to find that domain of the final. But really, we want to simplify the composite all the way down and then look at our difficulties, like is there a denominator other than 1, and is it a square root that we have to do a little bit more of. Okay, so here we have different f of x and g of x, so be careful. So we have f of g of x. So f of 4 over 3x minus 2. I'm going to rewrite f, but instead have this 4x, or 4 over 3x minus 2. Whew, look, got to do some algebra there, don't we? Okay. This is getting a little complicated. So I'm wondering if we could do this another way. Well, first of all, let's talk about g of x right there. G of x, what can't the denominator be? Well, in g of x, x cannot equal 2/3. Okay, so that's one of the things we have to keep in mind. The other thing I want you guys to look at is, first of all, I said 2 instead of 1, right? The other thing I want you to look at is that we have this 4 over 3x minus 2 minus 1. Now the idea is it's just saying find the domain, right? So do we have to simplify this all the way? No. What we need to remember is that our problem is that 4 over 3x minus 2 minus 1 cannot equal 0. Okay, because it doesn't say simplify, it just says find the domain. One of the things people forget is that you want to do that inside function first of what it can't be. Now we will have to do some simplifying. Now, instead of doing common denominators, we can just solve. So here I could say 4 over 3x minus 2 cannot equal 1. So I added 1 to both sides. Then, well, how do you get rid of a fraction? You multiply both sides by the denominator. So we end up getting 4 cannot equal 1 times 3x minus 2. Okay, and of course, if we say that, that 1 goes away and it's just 4 cannot equal 3x minus 2. And now we can solve. So 6 cannot equal 3x, and that also means that x cannot equal 2. So I have to keep both of these in mind when I write out my domain. Start out with negative infinity. Have to remember 2/3 comes before, so 2/3, and then 2/3 to 2, and 2 to infinity. So remember the inner function first, okay? So let's do that here. We have g of f of x, okay? So first of all, let's look at f of x. F of x, well, that's a square root. So what we do is we take what's underneath and we say that it has to be greater than or equal to 0. And then let's solve. So negative x is greater than or equal to negative 3. X, don't forget to switch the sign because we're dividing by negative, has to be less than 3. So this is our first one we have to keep in mind. But next, let's actually put in our f of x, okay? So what you want to keep in mind here square root. Now instead of x, we're going to put in the f of x, which is 3 minus the square root of 3 minus x, and then plus 2. If you guys, I just skipped a step right there. So remember, I'm saying g of the square root of 3 minus x. Okay, and this is how I get this. I don't have to worry about simplifying. What I have to worry about is that what is under the square root cannot be less than 0. So I can say the square root of 3 minus x plus 2 has to be greater than or equal to 0. And now I can solve. So square root of 3 minus x greater than or equal to -2. Okay, and let's look at this though. Is there anything that is going to be less than the square root, less than -2? Let's think about that. Any square root is going to be a positive number. So everything works. All works. All reals. Again, because you will never take a square root and get a negative number. Remember, they're all positive. So that means the only issue we have is that x has to be less than or equal to 3. So we go less than would be a negative infinity. And we're going to 3, and it's equal to. So we have a bracket. All right, guys, let's see. All right, so let's rewrite this g of f of 1. So if we plug 1 in for the f of x here, we would get g of 1 squared minus 4 times 1. Okay, that's just me plugging in 1 for f of x. So I have g of 1 squared is 1. 1 minus 4 is -3. Now, when I plug in -3 here, I would get 2 minus the square root of -3 plus 3. Oh, this one's nice, right? Because -3 plus 3 is 0. Square root of 0 is 0. 2 minus 0 is 2. Evaluated so much quicker. Let's try it the other way. F of g of 1. So we have f of 2 minus the square root of 1 plus 3, because I'm plugging in 1 for g. Then I have f of, let's see, 1 plus 3 is 4. Square root of 4 is 2. 2 minus 2 is 0. So when I plug in that for f, I get 0 squared minus 4 times 0. And my answer is 0. G of G6. So G of G of 6. So we get G of 2 minus the square root of 6 plus 3. All right, so G of, let's do this math. 6 plus 3 is 9. Square root of 9 is 3. 2 minus 3 is -1. Okay, so let's plug that in. So we get 2 minus the square root of -1 plus 3. Well, that's okay, because we'll just leave it as this number of 2 minus the square root of 2. There is no use of using the decimal, guys, unless the problem says round to the nearest third number. Otherwise, this is the exact number. All right, number 10. The surface area S of a sphere is a function of its radius is given by the formula S of R, 4 pi r squared. Suppose the sphere is being inflated so that the radius of the sphere is increasing according to the formula 3t squared, where t is measured and t is greater than 0 and r is in inches. You want to say t is greater than 0 because why would you have a negative time? So what this is saying is that we are taking the sphere and composite in the r of t, so the rate that the r is going up. So what I'm looking at is 4 pi, and instead of r, I'm going to put the 3t squared in. And don't forget that r for the sphere was squared. Okay, so instead of r there, I'm putting the 3t squared. Now, be careful on this because when you square, it goes to both. So right now, we have 4 pi times 9t to the 4th, which then reduces to 36 pi g to the 4th. One more, and we're almost done, guys. Okay, when we go backwards, okay, when we go backwards, we have to recognize functions that are given to us, okay? So what function do we see here, or what two functions do you see? Well, first of all, I see a function, that linear function of 3x minus 1, and I see the absolute value function. Okay, so I'm going to name these. I'm going to say this is f of x, and this is g of x. So what did I do to actually put one into the other? What did I put one into the other? I put the linear in the absolute value. So I put the linear inside the absolute value. So if we work backwards, what would this look like? This would be g of f of x. Okay. Now we're gonna do b in a couple ways because we could see two functions or we can see one function. Okay. So first of all, right away, the thing that comes out in my mind is that I see an x squared. And if I were putting x squared into something, I could be putting it into 2 over x plus 1. See how I would replace that? So if I name this f of x, and I name this g of x, what did I put into one? I put the x squared into the rational. So this would be g of f of x again, which interprets g of f of x. Now, there's another way I can do it. I could see three functions if I wanted to. I see an x squared. Well, if that x squared was taken away, I would see an x plus 1, which is linear in the denominator. And then that x plus 1, well, that can be interpreted as I'm replacing it under x. Okay, so it depends on the directions, how many functions you want to compose. So if I said this is f of x, this is g of x, and this is h of x, well, think of this. I'm putting the x squared into the linear. You see that? The x squared into the linear. So I would have at the very end the x squared that's going into the linear, and then the linear is going into the rational. This is interpreted as h of g of f, and we're done. So it all depends on what the directions want, if they want 2 functions or they want 3 functions. But this is showing you how you can do multiple. All right, guys, have fun with your practice work. And if you have any questions, make sure you ask.